Hello, Bart.
Hey, good morning. Well.
Yes.
Okay. Hello, everyone. This is the first time we're doing this on YouTube Live. It's testing for us as well. Welcome to the Mountain. It's the 14th Root Lab session. Today, presented by Nicolas Gelders, around the topic of basically a Terraform module that he made to easily deploy Airflow on AWS. Let me share quickly a slide to show who Nico is. So Nico is a data engineer at Dataroots. He's also the lead of the DevOps Guild, has a passion for DevOps, I think I can say. Likes Python a lot. Is an avid cyclist. Did a lot of competition in the youth. And is he calls himself a retired gamer, but we still have to hear a lot about it on a daily basis. Which I think sums up Nico quite well. You also see the meetup link. So if you're interested in following the next sessions, there's a next session planned in February again. Next one will be on machine learning services on Azure. And we're trying to pick up a monthly schedule again. I think the last one was the beginning of December, so it's a bit longer this time. But let's kick it off. I'm going to give the word to you, Nico.
Okay. Thanks, Bart. So, yeah, thanks. So, hi, everyone. So, as Bart said, I'm Nicolas. I'm a data engineer at Dataroots. Yeah.
Maybe I'm going to just shortly interrupt you. So if anyone has any questions, feel free to post them on the YouTube comments, and I will relay them to Nico for you.
Okay. Yeah. So, hi again. So today I will be talking about a Terraform module that we created. It's a Terraform module that deploys Airflow to AWS. So this is a basic overview of the presentation. First, I will give a brief context why we made this module. Then I will compare the different workflow managers on AWS. Then I will talk about what Airflow is. Then what and how we created the Airflow Terraform module, so a high-level overview. Then I will compare the managed Airflow that AWS now has with our module, and then I'll give a little demo. Okay, so let's start. The context. So a couple of months ago, more like a half a year ago, some of our clients were asking at the same time to deploy Airflow on AWS. At the time, there was not really a solution to that. There was no managed solution. So we decided to create a Terraform module for that so that we could reuse it and deploy it at these different clients. But now, like a month ago, they released a managed version on Airflow of Airflow on AWS. But it doesn't discredit our module. It's still relevant because it's a lot more flexible. And it costs a lot less, so it's between 8 to 10 times cheaper. So an overview of the workflow managers on AWS. First of all, what is a workflow manager and why do you use it? So it's mostly used to manage ETL pipelines. For example, if you have to keep track of 50 plus ETL pipelines, it becomes a real hard task to not have a tool that orchestrates all that. You need to keep track of which one fails, which one has to be rerun, and things like that. So the options on AWS are step functions, glue workflows, and now also the managed Apache Airflow. So if we compare them, we have step functions. They are fully managed by AWS. The scope is AWS, so you can use all the resources of AWS. So if you want to use Glue or use EMR or things like that, you can do that. But if you want to make it a workflow manager, you need to implement a lot of logic, Lambda logic. The overview of the UI is not very intuitive, and it doesn't keep a state out of the box. So you'll need to add an extra database, and you need to implement that in the step functions. Then you also have Glue workflows. It's also managed by AWS. But yeah, the scope is just Glue, so you can only use Glue crawlers or Glue jobs, and you can link them together, but you cannot use SageMaker or EMR, for example. And then now you also have the managed Airflow. The scope is general purpose, so you can do things on AWS, but you could also do things on Azure or things like that. The advantage is also that Airflow is the industry standard. It has a nice UI, keeps the state out of the box. It's fully open source, but one of the downsides is that it costs a lot. So if you have 50 DAX or more, it costs $500 a month, which is pretty expensive. So overall, the managed Airflow is the best solution, but expensive. A bit of a side note is that the step functions it's not bad, but it's not the right fit for this kind of job. You would use step functions more in the sense that you want to link different AWS resources together and glue them together. Okay, so now a bit, what is Airflow? So Airflow was originally created by Airbnb and now falls under the Apache license. It is a workflow manager, of course. And it's useful because it has a nice overview of all your pipelines. It has a nice UI. It keeps a state of all your pipelines, so you can see which one failed, which one succeeded, which one are running. You can easily rerun them with that state. You can implement notifications, monitoring, logging, etc., everything you need. So here is an overview of the UI of Airflow. So here you see all the DAX. So a DAX is a pipeline or a workflow. DAX stands for directed acyclic graph. So basically a graph where there are no loops. So it goes to from right to left or from left to right, top to bottom, but there are no loops in there. So here you can see the tasks in a workflow. So here 17 have passed. Here you see the DAC runs. So here 2 pipelines have run successfully. Now there are 5 running, and here you see that there are 4 that have failed. Then how do you create such a DAG or such a workflow? It's via Python. So this is the Python code you need to write to generate this. So here you provide a DAG context manager, and you define some tasks in there, and then you link the tasks together with the bitwise operator. And if you run this on the Airflow, you will get this output. So for example, here you would get the files from S3, you would put them in the data quality check step. Then if that passes, you put your job on EMR, for example, and you wait for the job to be finished. So now I will tell you about the Airflow module that we created. First of all, I will just start the demo already, and then I will talk about it because it takes like a couple of minutes to start up. Maybe I will talk about what's in here. So here, that's just the usual setup of which versions you use. And here you have our module. So you reference our Terraform registry. You give it some resource prefix, resource suffix. You define a VPC where you want to use it in. You define a public and a private subnet. If you just provide a public subnet, it will put everything in a public subnet. And if you provide a private subnet, it will put everything in the private subnet except the load balancer. It will put the load balancer in a public subnet. Then here we put HTTP false because otherwise you need a DNS record and all that, and I don't have that right now. Then here we put the Airflow executor. So there are 2 executors supported, sequential and local. The sequential one doesn't use a database. The local one does. Here we just put an Airflow variable. The one that I put here is the navbar color. So you will see that the color of the navbar will be orange. And then you have some RDS parameters. And we output the Airflow ALB DNS so we can connect to it. So I will just do Terraform init. So to initialize the modules. So it might take a minute. Okay, and now I do Terraform apply. So, and this will then deploy the module. It will take about 5 minutes, so I will start with the presentation again. So what was the intent to create this module? So we wanted to create as managed as possible. With that, I mean that we use like high-level services, like he says in RDS. It has to be low cost. It can be plugged in any infra. It's flexible, so you can choose if you want to have robust access control. You can choose the Airflow version if you want to use your own database, if you want to use HTTPS or not. And one of the things I want to hammer on is that it's only to manage your pipelines, is not to execute. So by that I mean that you dispatch all your jobs via Lambda or via Glue, EMR, or whatever, but you don't execute like SQL statements on the Airflow instance itself. Okay, so the approach, this is the basic overview of how the module is set up. So first of all, we have S3. Here we store all the DAGs, the plugins, and their entry points. So the entry points are actually the startup files that the containers use here. We chose it to do it like that so that we didn't have to manage a Terraform module repo and Docker repo. So we just have to manage one thing, and we just use the Airflow Docker, the Airflow-based Docker image with these entry point files to start everything. So then we also have RDS and RDS Postgres to keep the state of Airflow. Then we have a couple of containers. So the first container that gets started is the sidecar injection container. It just copies everything from S3 to a shared volume. Then there will be an Airflow init container that will start. This will run like the db init from Airflow and create a user if you have RBAC enabled. And then it will just run continuously the Airflow web server and the Airflow scheduler. And then you also have a load balancer to connect to the web server. And so if you provide private subnets, everything in here will be in a private subnet, and only the load balancer will be in a public subnet. Now we also put in testing. So we actually test the Terraform modules with different parameters. So I think we have now 6 or 7 tests in there. So we use terratest for that. It's something from gruntwork-io. What it actually does is just it deploys your module before a test. It destroys it after the test, and during you can easily assert cloud resources. So for example, if you want to make sure you have 3 AAM roles, you can do that. You can check the TF output. You can do HTTP requests to, for example, an EC2 or an ECS, and everything is written in Go. So the tests are written in Go. So here is a little example. So this is a test function. The parallel is to parallelize your tests. Here you get your you put in your Terraform variables and which model you want to test. This defer just means that at the end of the test, it will execute this method. So it will execute destroy. Then you do init apply. So it just deploys your module. Here you get the public IP from the output, and then you just do an assert to see if you can do an HTTP request to the service. So this is not something from our repo, but we do kind of the same. We do an HTTP request to our Airflow ECS web server, and we see if we can log in, for example, and we see if we can run the dash. Okay, now the usage. So it's very basic. So you have a couple of parameters. So you put in the link to our Terraform registry. Again, the prefix, the suffix, the VPC, the public subnet, the private subnets, HTTP. There are a lot more parameters than this, but these are the main ones. Then the outputs of the module, we have the ELB DNS. So basically, how you connect to the Airflow web service. Then you also have the task IAM role. This role allows you to give access to Airflow. For example, Lambda access to Airflow, or EMR access to Airflow, or Glue access to Airflow. And also you have the connection security group. This one is to, for example, connect your CI/CD to Airflow, so you could run DAGs via your CI/CD if you want to, or the Levy web service could also do it with that. Then the usage Airflow itself. So what I explained previously is just the infra. So normally this changes like once a month, maybe every 2 months. But the Airflow stuff itself, so the DAX, you change it daily or bi-daily. So what you do is you upload your DAX and plugins to an S3 bucket. Then you run the seed DAX. So I will show you that later. You wait for a couple of minutes, and you wait until your DAX appear. So it can take up to a little. It can take a while for the scheduler to pick up the new DAX, but yeah. So everything in here can be done easily via CI/CD, and so the sync DAX will. What it will do is just sync the S3 bucket with the ECS volume. Okay, so if we compare our module with the Airflow managed service of AWS, so the main difference is that the AWS is fully managed. Ours is like semi-managed, I would call it, because we use all managed services like ECS and RDS and Airflow, the base Airflow Docker container. We just use Terraform to glue everything together. Also, the cost of the managed service is a lot higher, like 10 times higher, and you cannot use an existing database with a managed one. And now time for the demo. Hopefully it deployed correctly. Let's see. No, it didn't. What for demo? Okay. Okay. Sorry, I will need to delete. So maybe it's time for questions, Bart.
This is the curse of the demo,
Yeah, but I changed. I know, but it will work. It will work. I know what I'm doing.
The curse of the live demo. There is one question from Juan, which is maybe more a bug report. He says that if he enables HTTPS, he gets an error. But maybe the proposal here would be to create an issue on GitHub. Yeah. Could definitely look into that.
Yeah. Okay.
Maybe a question I would have, Nico, because you created this, I think, well, you said it before the Amazon came with the managed service, or at least the general available one. In what situation today would you choose the Terraform module you have now versus the managed one? Like if you would, let me maybe rephrase it, maybe make it more concrete. If you would restart today, would you still use this module, or would you go for the managed one?
Well, the managed one, the thing is, it costs a lot. So if you're a big company and you can afford it, yeah, why not? But like also, if you have like over 50 DAX, it's $500 a month. Ours is like $50 a month. It's a big price difference, but if you have a big corporation and you don't want to deal with it,
And are there aspects in the managed one that would make it, let's say, more robust or something, more resilient?
Maybe. It's managed by AWS, so it will be.
There are SLAs on it. You can ping AWS if something goes wrong. You don't have in this case, of course.
You can blame them.
Yeah.
If you want to, there are problems.
Maybe a question about Terraform, because I think it's a very technical presentation. We're introducing a lot of topics here. So Terraform is used for infrastructure as code to basically define what you would like to see in infra in very clear specifications that then get applied. When would you start? Because this is not just, let's say, base Terraform. Here you created a module. When does it become relevant to start creating a Terraform module?
Well, you should always split up your infra in different modules to reuse them. But like for this, for example, we needed this because we have different clients that wanted exactly the same thing. So now it's just plug and play. We don't really need to do anything else. So the modules are really easy, just to the reusability. If you have a lot of the same things to deploy.
Well, in this case, it allows us to share it via GitHub, and you can make it more or less generic in a sense that you can parameterize a lot of stuff. You can use a lot of variables.
Yeah.
Which
But
is
you can
nice.
also just create private modules if you want for yourself. That's also a good way to do it.
There's another question. By default, your module uses Airflow image tag 1.10, but could it be moved to 2.0, which is maybe also something for the GitHub issues?
Yes, I think there is an issue about it. Okay, so yeah, it deployed. So we'll still need to wait a couple of seconds for the ECS to. Oh yeah, so we will need to wait like 2 more minutes.
Oh. Okay. Because I looked a bit at the terratest files, like it looks quite a lot of work to build these tests. How did you perceive building these tests for the Terraform module?
Yeah, at the beginning it's a bit hard because I didn't know Go in the beginning, but once you have like a baseline of Go, like it becomes not that difficult, I would say, and it's useful.
And what does it? Is it every time you change something to the module, you apply it to AWS and then destroy it if everything was successful, or how does this test workflow go?
Yeah, so when we do a pull request to the master branch, there's just a check that checks if the test pass. And yeah, it does like 6 or 7 tests with different parameters, I think. So sometimes it uses HTTPS, sometimes it doesn't. It uses RDS, custom RDS, things like that. So you can really parameterize your tests.
And it actually creates these resources in a AWS sandbox.
Yes. So we had a lot of issues in the beginning because we had limits of AWS, like there's too much snapshots created in this month and things like that. So.
Yeah. Okay.
Curse of the demo.
The curse of the demo, indeed.
So yeah, the reason why, voilà. Okay. So as you see, here's an example DAG, and here is the seed DAG. So if you run this, it will sync everything with the S3 bucket. So now if I go to the S3 bucket that we created, we refresh. So it's this one. I will upload a DAG. Okay. So folder. Okay. Just put it in here, upload. Okay, and now we just run this DAG. And it will sync S3 with the ECS volume. So if you wait a couple of seconds. So if you go to this task, in the logs you will see, so this is a list before. So you see here we have the 2 DAGs, so the seed DAG and example DAG. And once the list after is done, you will see that here you have the root labs DAG that I just uploaded here. So if we go back, we have these 3 files, and these are the same. So normally, yeah, it takes a while for the schedule to pick it up, but in a couple of minutes again it will show up. But yeah, maybe, yeah, Bart, I think we can close it here.
Okay, we have another question from Peter. When using an RDS database for stateful operations, which databases are supported? Postgres, SQL Server?
Yes,
or others?
Yeah, Postgres and SQL.
Okay.
MySQL. But I would suggest just using Postgres. That's the one Airflow recommends.
It's the default for Airflow, Postgres.
Yeah. Oh yeah, you can still choose. You just put the link to the SQL database.
Peter just posted another question. Could you also show the ECS screen?
Yes.
Are these services, tasks, Fargate?
Yes, they are.
Let me put your screen back.
So here, these are tasks. So it's one task with 2 containers in it because we wanted one shared volume. So here you see the 4 tasks. So these 2 are the ones that initiate it, and then we have the ones that run continuously. Don't know if you want to see more.
I think that was the question, yeah, from Peter. Okay. I don't think we have any other questions. And, it's 12 o'clock, so I'm gonna say thanks a lot, Nico. Very interesting presentation.
Thank you.
I think the details on where to find the Terraform module are shared in the meetup description.
Right, I have a slide here. So
Voilà, indeed. Yeah. Maybe we can add the slides to the meetup description as well. Be interesting. Yes. And if you are interested in following a next session, the next session will be on using how to use Azure for machine learning jobs. Also an interesting topic. That's why I hope to see you next time. Thanks a lot, everyone.
Okay, bye.